नमस्ते दोस्तों. I hope you are fine, doing well in your life. So we are gonna start with LeetCode 75, right? So we have solved first problems of all the topics till monotonic stack. Now we are started with the second problems. So we have solved the second problem of array, two pointers. Now we're gonna solve the second problem of sliding window. So let's begin with the problem. Before starting the problem, I will let you know that we have solved the LeetCode problem of the day and uploaded the video over my YouTube channel. So you can visit that video also. That is a very interesting problem of backtracing. So I suggest you to, if you haven't solved the problem or if you haven't solved the problem using backtracing, right? So you can go through that video. So that will be very helpful. Also, I have shared the link of a WhatsApp group in the description box. That is a group I am creating for making a community of the coders like you and me, right? So that will be helpful for every one of us. So we can ask our doubts, we can discuss some good problems, good algorithms, and we can also start a good project which will be helpful, which will make our resume stronger. Along with that, we can start some projects for freelancing work also, which will be beneficial for our monetary for our which we can also get some money, right? So that's so let's start with the problem. So this is the problem of sliding window. So what we have to do, so actually I have solved this problem and I have also created the video, but unfortunately due to some technical error the video I haven't created well. So I am again gonna solve this problem and explain it to you with the same energy. Don't worry. So the problem is maximum number of vowels in a substring of a given length. So the problem is very simple, very straightforward. We have given a string and an integer k, right? We have given a string and an integer k. We have to find the maximum number of vowels in a substring of length k. So substring is nothing but a continuous part of a string, right? So in this LeetCode, COD is a substring, but COE is not a substring. It's a subsequence, right? Or we can say subset. So we have given a string, we have given k. We have to find the maximum number of vowels in a string. This is a pretty straightforward solution problem from sliding window, but we have a rule, right? So we are gonna discuss the details, then we will discuss the native approach. If there is any possible native approach, then we will gonna try to optimize that native approach using like in an optimized manner, right? Anyways, so this is the structure for any interview, so using this structure this will be very helpful for us to crack any interview also. So details are very straightforward. We have given a string and we have given k. We are expected to return the maximum number of vowels which can be present in any substring of length k, right? So that's all in the details. So how can we solve this problem using native approach? How can we solve using natively? So what we can do, we can iterate through the character. We can iterate through any character, right? So every character, and we will find the number of vowels in the next k characters, right? So let's say we are at a. What we can do, we can iterate through next 3 characters till c, and there is one vowel, so we'll count max at as equals to 1, right? So this is nothing but max. Now we'll iterate at b and we'll find the maximum number of we will find the total number of vowels in this window. So that is 1, so max will become 1. So this is how we're gonna iterate through whole array and find the maximum number of vowel in any window of length k. So the time complexity is, we have to iterate through array in n iterations, and we have to iterate through the window of length k. So time complexity will be n into k. Space complexity is nothing. So space complexity is nothing. Actually, at that time I was thinking native approach as like we are gonna make all the substrings and then we'll find the number of vowels. So that is another native approach. So native approach is nothing but the solution which came in the mind at the first place. So how can we optimize this? So let's say we have A, B, C, I or D. So we have this string. How to optimize this? So there is a concept called sliding window, in which we will create a window of length k, and then we will move that window to the right. So we will iterate that window, and we will update the constants in the window. So that is the basic structure of a sliding window approach. So we will make a window of length k in the first place and count the number of vowels in this window. So we have one vowel in this window now, right? So when we slide right to that window, what we can check that if any vowel is getting inserted in this window. So yes, I is getting inserted in this window. So our count of vowel will become 2 now. But we have to also check that if any vowel is getting out of this window. So yes, A is a vowel which is getting out from this window. So count will again reduce to 1. So total vowel count will become 1. So in this case also the maximum max we will track the max. So max is still 1. Now we'll again iterate to the right. So we have to check that any vowel is getting inserted in this window. So yes, I is getting inserted in this window. So the count will become previous count plus 1. So previous count is 1. So our count will become 2. And if any vowel is getting outed from this window, so no, B is getting out from this window, but that is not a vowel. So this count will not get reduced. So the maximum will become 2 now. And then we will again shift the window to the right and check if the inserted character is a vowel. So no. So we will not increase this count. And is the extracted character is a vowel? So no. If that will become the vowel now, so we will reduce that count. So our maximum remains 2, and you can also verify manually that we can have the maximum 2 vowels in any window of length 3, right? So that's the solution from sliding window, right? So as you can see, if we inserting any vowel, we will increase the count. Also, if we are exiting the vowel, we will decrease. So that's all we need to do. So this is the coding part. Let me explain it to you. Okay. So we are creating a dictionary of vowel to check if the character is a vowel or not. We are making a maximum count and we are making a current count, right? We are iterating through the k, means we are creating a window here. So let's say this is the string, we are creating a window here. So we are counting the vowels, right? And we are initiating the max count is equals to count. So if the number of count in this window is 3, so the maximum count is still 3 at this point, right? Then we will shifting this window to the right. So I is representing the start of window and I plus k. Okay, so sorry, I is representing the end of window and I minus k represents the start, right? So we will start iterating from this k. So we have the window from 0 to k minus 1, right? Now we will start from k till length of s minus 1. So the I will the end will become now k, and the start will be 1. So we'll this is the second window. Then 2 से लेके आगे तक k+1 3 से लेके k+2, so that will be our second and third window. So this is the iteration for that. This is the loop for this, that right shift right. So if I minus k, so that means if the exiting character is a vowel, is in vowel means is a vowel, so we will decrease the count. And if the inserting character is a vowel, so we will increase the count. And also this indicates that if we have the count is equals to k, if we have all the character inside this window is count is vowels, right? So that means that is the maximum possible answer. Any number of characters which can, so maximum number of vowels in any substring of length k can be k, right? If that is the case, so if this is possible, then we will turn k, so that we can eliminate some iterations also, right? So otherwise max k will be the maximum of max k and count. So we will track the max k here and we will return. So that is the code. That is all from this problem. So I hope you understand this problem well, and as well as this solution. I am trying my best to explain you everything, every small to big details in every problem. So this video is a part of LeetCode 75 series which I am trying to solve. So I have solved more than 15 to 16 questions from LeetCode 75 and uploaded the video. You can go through those videos as well. Along with this, I have also started the a video series of LeetCode problem of the day, where I have submitted more than 30 videos of LeetCode daily problems. Due to some personal reasons, I in between I was unable to upload some videos, but yeah, I was trying to my best to upload each and every question of LeetCode daily, as well as I will complete this LeetCode 75 series very soon. After that, we will start some code series also again. So it's your choice if you want to subscribe me or not, but I suggest you to join that WhatsApp channel which I have shared the link in the description box. That will be very beneficial for all of us, including you. So that's all from my side, guys. Thank you for your time. Thank you.